So we want to talk about, so the next phase of Valhalla is to have specialized generics, and we want to talk about it. We have no solution, we have only problems. And this is a TLDR of the talk. This is a nice character, but with really big teeth. I don't know if you know this movie, but my son really likes this character, but at the same time, it has really big teeth. So I'm Rémi Forax, and this is Loris. Hello. We are from the Gustave Eiffel University. So basically, Gustave Eiffel is the name of the guy that creates the Eiffel Tower. And the university is not related at all with Gustave Eiffel, apart the fact that it has the name of Gustave Eiffel. What we are showing currently is a research work. It's not a product. Please, please, please don't use what we are saying as something that will happen in the future. Maybe it will happen, but maybe not. So I will start with stating the problem. So currently, value type is something which is solved only at runtime. Basically, when you have a value type, what you can do is take a type which is a classical class and that just put value in front of it, and it should work. Basically, with the early access build that was released last week, you can see that optional is now a class with a value stick in front of it, and it's backward compatible. It's even more than that. It's backward compatible and forward compatible, which means that you can put value in front of a class or you can remove value in front of a class. It should be binary backward compatible, which means that all the optimization has to be done at runtime, because only at runtime we know if a class is a value class or not. Nothing is done at compile time. So the only thing that I've done at compile time is verifying that the class has the strict fields and so on. So basically, value types are only optimized at runtime. And at the same time, generics are not available at runtime anymore. If you have a list of complex, and the complex is a value time, at runtime, the only thing you have is a list. So there is a big mismatch between how we see value types and how generics are currently implemented because of erasure. So the real question is how to specialize something like a list of complex. The answer is we have to change the way generics are currently implemented. We cannot have erasure. The real question of this talk is what we can do. So changing the generics is usually referred as type specialization. And type specialization is a kind of a spectrum. We can do several things, and we are not sure exactly what we can do in a backward compatible way. So there are several levels. Let's say the level 0 is just we need the type argument for only two things. If a field is declared with a bang, if it's a T bang, we need to know that the type of the T, which means that we need to have the type argument at runtime when we store the value. So on put field, and this is the same for arrays, which is basically the teeth are when you do a put field or an array store, because in both cases, the VM will have to check that the value is not null before inserting it in the field or in the store. So this is a level 0. We know that if we don't have that, we don't have specialized generic. But we can go further. We can say when you declare a method, if you have a string bang or if you have a T bang, then we will check the VM will check at runtime that what you call as is not null. So we can do that at method entry. We can do that at method exit to check that the return value is not null. And instead of doing that at method declaration, we can do that at method call too. So we have several options to choose where we can bite people. And we have the next level, which is if you have a list of complex bang, when you do a cast, should we check that this is really a complex bang? So should we check at the type usage that the specialization is the right one? Currently, because you have erasure, the VM doesn't check at all that you have a list of string, only that you have a list. The main issue with checking all these things is the more you check, the less backward compatible you are. And at some point, if you do too many checks, there will exist no program that will run with the new type specialization. That's why it's a spectrum. The question is where to put the bar. So just to be sure, an example. Let's say array list of complex is like array list of complex bang. So I have an array list of complex. I put it in a list of complex. Obviously, we want to support row type. So if I have a list row, I can put my array list of complex and see it as a list. If I call the method add on the row list, is it okay to do that? I mean, currently it works. But if we start to enforce that when you call a method, we check that the argument is a complex, 42 is not a complex. So this code, which is currently valid in Java nowadays, will not be valid anymore. And what if we have a cast? Let's say I take row and see it as a list of objects. Again, currently it works. I mean, I can just call list.empty after, and it will work. So it's a valid code currently, but if we add teeth in your type specialization, it may not work anymore. We cannot be 100% backward compatible. Because in that case, it means that we cannot do a check when you do a store in an array or in a field. So basically, it means that there is no type specialization. So we know that we cannot be 100% backward compatible. That's why it's a spectrum. The question is what we should target. So we have done an experimentation, or exactly, Loris has implemented everything. I have done nothing, just said, that's good. The experiment is to patch Java-C to propagate the type and to see on existing code if the cast can fail or not, and just take existing programs and run as the prototype. We call it Diego, obviously, and see if there is a lot of runtime checks that will fail or not, depending on the different level, depending if we check the method entry or if we check the cast. That will give us the level of compatibility. Currently, we are in the early phase, so we have only tested on JDK code, not other code. Currently, the existing code is not fully what we want. Because if you take a look to an array list of E, currently the array is an array of objects. So even if currently we check your code, it will not be the code that we want if we have type specialization. Because if we have type specialization, it should not be an array of objects, but it should be an array of E. And by the way, an array of E is something very dangerous. Because if you have an array of E, even if if you create that array of E, you have to be sure that this code is really specialized. By that I mean fully specialized. We cannot create an array of E only if it's a value type. Because if we have a strategy like I will do specialization but only for value types, then this code doesn't work if E is a string. Because in that case, it will create an array of objects. Because string is not a value type, and it will fail on the next cast inserted by the compiler. The cast in green here is inserted by the compiler. You don't even have to do something. It's how the erasure currently works. Which means that a kind of partial strategy to say, I will only specialize if it's a value type may not work. So currently, we are only testing existing code, which is not exactly the code we want. And remember that we have some trouble if we only specialize for value types. So I will let Loris talk about the prototype.
As Rémi said, the idea of the prototype is to be able to, for each level of the specialization on the specialization spectrum, to know how much it will break the existing code and do not respect the backward compatibility. So, because the prototype isn't the actual solution with our problem due to the erasure, we do not care. We do not need to care about performances, because we only want to know, as I said, if for each level, if its implementation is feasible. So we do not care about performances at all. And considering this, the prototype can work only by patching the Java compiler. We do not need to modify at all the VM, which will produce a prototype with much better performances, but once again, we do not care about performances. However, what we want is to be able to run this prototype on as many code as possible. So in this regard, it is really important that the prototype support the whole Java specification to be sure that any Java valid code could be recompiled by the prototype. Also, it has to work really simply, because we do not want to have a lot of steps to follow before being able to run the prototype on a code. So the idea is we just have to recompile an existing source code, and that's it. It will insert all the necessary, the required, checks in the produced class files. And also, to be able to use the prototype with any code, because most of programs have a lot of dependencies like libraries or frameworks. It is really important that it can work even with the newly compiled code and legacy code that hasn't been recompiled, because otherwise we will have to also recompile all the dependencies of our program and the dependencies on the dependencies and so on. So that's why it's important that the prototype handle the separate compilation. So now I will talk about more in depth about how the prototype works. So the idea is to, as we said, to propagate the type information during the runtime. So to do so, we have two new types. We introduced two new types. The first one being the arg type, which will represent, among other types, the parameterized types, so like list, collections, and so on, and which will be stored in any parameterized type and retrieved when we need to use this information. So for example, in the case of an array list, when we will create an array list, it will store the type information in a newly generated field. And when we will want to check the type of this array list, we will access this arg field. The second introduced type is the method argument, which is a little bit different. This one will only serve to propagate the types information of the generic methods. It will never be stored or like the arg. It will at most be used to create args that will be stored, or to perform cast, but it will never be stored. So because it's semantically different, we have another type to represent this. To be clearer, let's now look at an example. We have a simple generic class, so an A class parameterized with an E, which also declare an E field. and also a generic method of parameterize with a T argument. The first step of the prototype will be to propagate the type argument information. So as I said, we will generate an arg field, which will contain the information about the E of this A type. This field will be instantiated in the constructor, which now have an additional parameter to propagate, to reach the constructor and to be able to set the field. And you can note that the set of the field is done before calling the superconstructor, because we want to be sure that all the arg fields are set before any subsequent call. So that's why we do the initialization before the super call. And for the auth method, we also have an additional parameter of method arg type, which will be used, as we can see in the return of the method in the instantiation of an A object to construct the parameterized type representing the newly created object, which in our case is an A parameterized type A of T. Then once we have the type information propagation, we now can use this information to perform some casts. So one of the level of the specialization spectrum was to add checks at method entry and exit. So we can see that we now have a call to a method named checkcast in the first line of the constructor, which will take an object of any type and a second parameter representing the expected type for this object, and will perform a check to ensure that the provided object is of the correct type. And this kind of cast will be inserted for each parameter of parameterized type, or using directly a type variable, in our case, E. It goes the same way, so for the parameter T in the auth method. And also, we need to insert casts for the returned types that are, once again, of parameterized type or type variable. So we here generate a check cast to ensure that the return A is of type T and not any other type, which in this case is obvious because we created the same A with the same T, so it will always be true. The another level of checks was to add checks when we store fields, for the put field. So here we also generate a check for before setting the value to E. But you can note that this time, because we know that the arg field has been initialized, we this time use directly the field instead of the parameter, sorry, of the constructor, as we were doing for the checkcast and the E and the method entry. So this time we can use directly the field instead of the parameter. So I previously said that it was important that the prototype handles separate compilation. So to achieve this goal, we had to generate methods that will behave like that would make the recompiled programs be able to behave as they were doing before the recompilation, to ensure that any codes that hasn't been recompiled could still call all the methods of our recompiled code. So we had to add methods that do not have the arg and method arg parameters to ensure this. And also these methods had to be synthetic because we do not want that the recompiled code can see this method and call them instead of the method with the additional parameters. And we also had to add a new attribute flag on the generated classes because we do not want to look into a class to trying to find a method with an arg parameter if the class hasn't been recompiled and one will never have this kind of methods. So to make the difference between the new and the old classes, we have added a flag. And finally, to be able to handle the separate compilation, we had to be able to handle the inheritance in the context of row types, which is quite complex. So for the first part, as I said, in addition to all the previous modifications, the prototype will generate some synthetic backward compatibility method. For the constructor, it will simply call the new constructor by using with a default argument. Here in our case, it will instantiate an A of row type A. And for the off method, it will call the new off method with T being an of type object. And this time for the question of the inheritance with the row types,
let's say it's a kind of a game. It's a question for all of you. Is the cast here safe or not? So, yeah, by raising your hands, who thinks this cast is safe? Okay, not a lot. Who thinks this cast is not safe? Okay, so it seems so it seems you have no idea if a cast is safe or not. I mean, it's only one line of code.
And the answer is no.
So no, it's not safe. It's not safe because when you do a new B, you create a new row type. And when you create a row type, then its super type is a row type 2, which means that the yes, exactly. So the super type of the new B is just high, not high of something. Even if it, yes.
But B of anything implements I of string.
It's not what the specification of Java says. I mean, this is what is written in terms of code here, but it's not how Java works.
So one question, if the type is B wheel card, then it's I string, right?
Yes.
Yes.
If it's a wildcard, yes. But if it's a row type, no.
So To handle this behavior in the prototype, we had to do the following thing. So first, we have this time two fields, one representing the arguments of B, and one representing the arguments of the I interface. And what we had to do is, when it comes to the B parameter field, we do not need to change anything. But this time for the I, we need first to check if the arg parameter is a row type. And if it's a row type, we need to propagate the fact that this instance of B is a row type to ensure to keep the behavior from the previous slide. And in the case of where the arg is not a row type, we can this time simply set a parameterized type I of string. So that was for the interesting part of the implementation of the prototype. Now I will briefly talk about the modification that it implied in the Java compiler. First, we had to add a new phase that occurs at the beginning of the disregard, and of course before the erasure, because we need the type information to be still present. And also we had to save some type information in lambda and method references, because we also want for the instances of the hidden classes created by the lambdas and method references to have an arg field. So we had to modify the method in the lambda factory and all the declaration of the lambdas. But we also had to modify how the static methods used by the lambdas are generated. And all these things are done in the unlambda phase, which occurs after the erasure. So we had to first store the information to be able to retrieve it later when it has been erased by the erasure. And finally, we had to disable, or at least reduce the cases where we can benefit the optimization of the inner classes. When you declare an inner class, if the outer this reference is never used, the compiler will not add an outer this field in the class. But in our case, because we want to be able to check things like full string that bar integer, we always need the outer this field to be present, because when we want to check an instance of bar, we also need to ensure that the outer type, in our case foo, is of type string, because this parameter also took in account when it comes to the type of bar. So this was all for the implementation, but now maybe we can talk about the results. So for these are the results only for running Java-C and building the JDK. So we can see that even for a project with well-written and maintained code, we still have a lot of failing checkcasts. And we also can see that most of them come from the level implying the method entry and method exit checks. And I think it's...
I can go from here. So we run, so basically when you build the JDK, the compiler compile itself and then recompile all the classes. So these values are just when the new compiler recompile all the code of the JDK. And it doesn't run the JDK. So this is only a test of the compiler. We try to categorize the different kind of errors. So the first kind of error we have is when you try to create a singleton in Java. So in I don't know if you know the source code of the compiler, but there is a singleton called list.nil, which is equivalent to an empty set or an empty list or things like this. If you take a look to the code, we have a field named empty list, which creates a list of objects. And then we have a static method nil that sees this empty list as a list of A. Obviously, if cast has teeth, this is not a valid creation. So we have a lot of issues like this in all the immutable collection of Java util or empty list, empty set, and so on. There is a way to fix this if we want, because this is clearly the type system of Java is not expressive enough to express this kind of thing. But we know if we take a look to something like Scala that they have solved this issue. Or is it Scala or Kotlin? Something like this. In that case, you need two things. You need a new type. Let's call it Java long nothing. Usually goes that way, which is a subtype of any type. And you need a way to declare that when you have a class like a list, which is immutable, this class will be always covariant. And if you have both these things, then you are okay. All the cast will work. I think it's basically your a part of your PhD thesis, which is about how to implement this kind of thing. I have only read the summary. I have not read. Okay, that's okay. But, so this is something that can be done, but it's not a small feature. We have other example of failed cast. So I have only picked one method in the stream API. We have an abstract pipeline and a method called wrap sync. There is something which is really great at the JVM submits is that we have all the people that have written this kind of code. So we have Paul here that have written this code. I have no idea exactly how it works. We spent some time to try to understand it, but clearly our prototype Diego doesn't like this code, the cast here. If you don't do one loop, you have something which is parameterized by e out, and you just cast it as a p.in. So maybe it works, but clearly there is something weird here. This is a kind of code that works in practice because what is done on the sync after calling this method, it's not something that will use a type argument, basically. But if cast has teeth, it's a huge issue. And fixing existing Java codes is far harder than fixing the problem of the singleton. Why? Because erasure hide type bugs. You don't saw it. The only way to fix this is that everybody, I mean here and in the whole world, has to fix their code. Usually it's not a good message when you start like this, but it's worse than this. Because you have to fix code which is unrelated to value classes. You are fixing code for the generic parts that maybe never use or never see a value classes. So it will be hard to motivate, let's say us, to rewrite our code, to change codes which may be unrelated to value classes. We can help. We can try to release a tool similar to our prototype. So do a kind of so it's not a static analysis. You have to run the code, but you can put Diego in your CI and take a look to all the warnings. But basically, it means that if we want to do type specialization, and I think we should do type specialization, we have to be careful on the what level we want to have, because it's quite easy, even on well-written code, to see this kind of problem. So type specialization is a spectrum. We don't have to do full reification. If we do full reification, no code will work. I mean, we can't even build the GDK. And we only take 2 examples because there was a long list of. It's a Java problem. It's not a Java the platform problem. This is very specific to Java. I have no idea if language like Kotlin or Scala have this kind of problem, because it's not exactly the same semantics. So each language may have a different threshold in terms of type specialization. So if you take a look to the proposal of the parametric VM, the parametric VM doesn't define a semantics for the generics. It's up to the language to implement how they want to erase things or things like this. So it's a work that has to be done language per language. The other thing is that we have a prototype. We run it on other projects, but we were not able, taking a look to the code, to be able to be sure if some casts were right or not. We are asking for help. If you have a library and you want to run Diego on it, we hope that we don't have false positive, but we cannot guarantee this. So we need you. The code is available at this GitHub repository. Now, if you have any question,
Good work. That kind of throws me back in time when I was working on similar problems. So for the singleton idiom, which it is indeed very common. Now that we have value objects, will be very expensive to create a new list every time that you call like list.nil. That will not require type system modification, right?
Yes, the main issue is that in the code, you have a lot of equals, and people rely on it. It's really an issue. We had the same kind of issue with optional.empty. And so we take a look to this code, and we found some JUnit test that was testing if an optional was empty, not by calling isEmpty on it, but equals optional.empty.
So for the second kind of like the like arbitrary cast you've discovered, have you actually discovered any real cases where the cast is actually problematic? Because I mean, like as a part of like JDK development, we have actually encountered a case like, for example, if you look at priority queue, it has like a copy constructor that copies another collection. But that collection, and it tries to get a comparator from the other collection, which may be of a more specific type. And and this priority queue is using a more specific comparator, which will break when this priority queue is added new items. So, like, have you actually find such actual like arbitrary casts that are actually problematic?
So the answer is no, because if we run gtreg on the whole thing, so we said that we don't care about performance. Actually, this is an issue. We try to we create too much arg, and so I don't remember how but usually when we run Diego, it takes sometimes in minutes or half hour. So if we try to run it on something which is quite big, it takes a long time. And this is something we will have to revise and try to have a strategy to share more more code. So no, currently we have a little experience on running Diego on. We try several really small things, but not big code. Okay.